Okay, so welcome back to our another video lesson for grade 10 mathematics. So for this week, we will be discussing the module 4, the deriving, inductively, the relations among chords, arc, central, and inscribed angle. So by the way, I am Ronel C. Fernandez, your math teacher. Together with me are your math teachers also, Ma'am Marianti Salisi and Ma'am Pap B. Ladera. So let's start. So for this module, you should be able to derive inductively the relations among chords, arcs, central angles, and inscribed angles. So moreover, you are expected to first is define and identify chords, arcs, central angles, and inscribed angles. Then describe inductively the relationships between circles, and lastly apply theorems of chords, arcs, and angles in solving problem. So let's proceed now to lesson 1. In your module 4, I hope you are seated in a comfortable place and you're holding your module. So lesson 1, terms related to circles. So starting module 4, we are in geometry na. So the first topic is all about circles. So let's define first some terms. So we have chord, arcs. We have also the figure. Okay, so we have chord. So this is the figure. Of course, this is a circle. So this is the center. Okay, the center B. Okay, a chord. Let's define what is a chord. A chord is a segment. What do you mean by a segment? So a segment is a family of lines, no? That we have it has two endpoints, no? Siya endpoint. So for example, we have a chord. This is a chord, okay? We have chord AB. Oh, sorry, a segment AB. Okay, meaning we have two endpoints, the point A and point B. That is a segment. Which endpoints are on a given circle? So the example in the segment AC, meaning this segment is this is how you will write it, is a chord of circle B. So you will read this as circle B. The name of this circle is circle B. This is how you will write the circle B. Okay, so you will name the circle using the center of the circle. Okay, so this is a chord, meaning a chord which endpoints are on a given circle. So point A and point C are points on the circle. Okay, that is a chord. So what is an arc? So an arc is a part of a circumference. Okay, a circumference of a circle. What is a circumference? So circumference is that is the measurement around the circle. Sorry for my circle. It was a circle na. It is named by their endpoints. It can be read clockwise or counterclockwise. The symbol for arc is this one. Okay. So example, the curve from point D. Okay, let's erase muna no. The curve. Okay, wait lang no. Okay, the curve from point D, meaning from here, to point A is an arc. Meaning this one is an arc. Of course, an arc is meaning that to sa iyahang circumference a circle no part of a circle, which can be read as arc DA or DA. This one, okay? Arc DA. Okay? Other example of arcs are in the left figure are arc DAC. So you can name this as arc DAC, this one. Okay, this is DAC. And we have arc ACD. We have arc AC. This is C, no? This is C. Arc ACD. So this is an arc also. We have also CDA, meaning this one. No, sorry. Okay. So an arc, again, that is a part of a circle, meaning circumference na part na kani. Okay. That is an arc. So this you will use this symbol no for an arc. So we have also we have types of arc. We have semicircle, minor arc, and later we have my major arc. So a semicircle. Okay, so an arc, I think you are all familiar with semicircle, meaning half of a circle. An arc with a measure equal to one half of the circumference of a circle that measures 180 degrees. It is named using two or three endpoints of the arc. Okay, so in this circle, this is circle B. So this is circle B. So the semicircle is this one. Okay, the arc AC, or you can name it as arc ADC. No examples. Okay, don't forget the symbol part. Okay, you can name it using two letters, or you can use three letters. So that is a semicircle. Minor arc. It is an arc of a circle that measures less than a semicircle, meaning a minor arc is less than, meaning that is shorter than a semicircle, or 180 degrees. It is named using two endpoints of the arc or three endpoints as long as it measures less than 180 degrees. Or a minor arc is an arc that is less than a semicircle, meaning it will not go beyond, okay, dili siya mulapas, it will not go beyond the semicircle. Okay, example 2, what are the minor arcs of circle B, meaning this one? Okay, so what are the minor arcs? You can name it as this one. This is a minor arc. Okay, diba the semicircle is this? So dapat it should be less than. So this is arc AC. We have this one, and also have arc AD. Okay, and also arc. Okay, using this circle, no, arc ACD. We have arc ACD. This one, no, you can name. Okay, this is also a minor arc. Okay, by looking at the arc, you can say na it is a minor arc, a semicircle, or a major arc. So a major arc, it is an arc of a circle that measures greater than, okay, from the word major, no? Greater than the semicircle. It measures greater than 180 degrees but less than 360 degrees. To indicate the major arc, we must include the point between the endpoints of the arc. Example, in this figure, we have circle B, we have A, C, D, meaning this, okay, no? You can see, no, this is a major arc. No, it's more than semicircle. We have also have C. Okay, we can use another color. We have CDA. C. This is CDA. Okay, this one. No, this is also a semicircle. Okay, so we have also major arc. What are the major arcs? What are the major arcs of circle B? So we have CAD, C A. Sorry, CAD. So of course this is a major arc. But it go beyond the semicircle that is already a major arc. Then DCA. Okay, we'll use another color. DCA. DCA. Okay, this is a major arc also, no? Then we have ADC. Okay. ADC. Okay, this is a major arc. Okay. Again, you can name it CDA or ADC. Okay, either of the two. Okay, next. Intercepted arc. So intercepted arc is the arc that lies in the interior of an angle and has endpoints on the angle. So this is a circle. Okay, arc BC, meaning this is arc BC. Diba? This is arc BC. Ang point B, this is point C, and point A. Is an intercepted arc of angle CAB. Okay, meaning this is an angle, right? Then that this is the intercepted arc. Okay, meaning the angle, the arc opposite of the angle, no? So yung this one. So asa nagatubang ang angle, that is an intercepted arc. For this example, we have this is an intercepted arc, the arc AC, and of angle ABC. Okay, that's for the intercepted arc. Okay, for the angles, we also have angles, a central angle and inscribed angle. A central angle is an angle whose vertex is at the center of the circle. The sides of the angle contain 2 radii of the circle. Okay, so again, a central angle, the vertex is the center. Okay, so for example, this is angle ABC, or you can write this, or you can write the symbol angle ABC. Okay, you can see now B is the center, that is the vertex of our angle, so meaning this is a central angle. And this is a radius, no? This is also a radius. We have inscribed angle. Inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle, meaning this is your inscribed angle. This is what? Okay, versus this is intercepted arc, and this is a chord. Okay, so again, the difference between the two, the central angle, the vertex is the center. For inscribed angle, the vertex is on the circle. Okay. Okay, points of the inscribed angle. In figure 1, the center of the circle is on the side of the inscribed angle, or the diameter of the circle. So angle PEN is the inscribed angle, intercepts the arc PN. Okay, so meaning this is the diameter, no? Since this is the center. Angle in figure 2, the center of the circle is in the interior of the inscribed angle. So angle AGP is the inscribed angle and intercepts arc AP. In the figure 3, the center of the circle is the exterior of the inscribed angle. Angle IHS. Okay, this is the intercepted. Again, this is exterior, no, na sa gawas ang center. This is interior, and this is on the diameter or on the chord of the circle. Okay, let's proceed now to lesson 2, arcs and chords. So we have theorems. So first theorem, in the same circle or in congruent circles, congruent arcs have congruent chords, and congruent chords have congruent arcs. Okay, for example, if this chord and this chord are congruent, it follows that the arc, sorry, let's change the color. It follows that this arc is congruent to this arc also. Okay, if this chord and this chord are equal or are congruent, it follows also that the arc are also congruent. Okay, that's the first theorem. Okay, if TE, meaning the arc TE, again, symbol arc is congruent to SP, then the chord TE are congruent also, or vice versa. Okay, again, if congruent ang chord, it follows that the arc are also congruent. Okay, for example, find the value of x if TI, meaning TI, okay, TI, this one, is 3 cm, and of course EM is 3 cm. So, since find this is our x, since this is 75, since 3 man is siya and this is also 3, it follows that if this is 75, this is also 75 degrees. By the way, the unit of arcs, no, the unit of our arcs are on degrees, no? Dapat it should be in degrees. Okay, it follows that this is 3. This is 3. So therefore, if this is 75, this is also 75. Okay, so next, we have in the figure C, circle D is congruent to circle J, and SC, this chord, oh sorry, this arc is congruent to TO, meaning this arc. Find SC, meaning this one, given that 8y minus 1 and 15y minus 15. Okay, so since our arcs are equal, it follows that the chords are also equal. Okay, so therefore, therefore SC is congruent to, meaning this chord is congruent to OT. Okay, so therefore our SC is 8y minus 1 equals 15y minus 15. Okay, this is just algebra. Combine like terms. If we're going to transpose 15y to the other side, it will become minus 15y equals negative 15. This minus 1 will become plus 1. Okay, so 8y minus 15, that is 7y negative. Okay, this is negative 14, right? Then divide both sides. Negative 7, negative 7. Y is? Very good. This is 2. Manaba mo or are you done with 2? Okay, after this, again take note, find the segment SC. So our SC, diba, our segment SC is equal to 8y minus 1. Since our y is 2, that is 8 times 2 minus 1, that is 16 minus 1, and that is 15. So therefore, our SC, or the length of SC, chord SC or segment SC is 15. Okay, take note with our theorem 1, if the chords are equal, the arcs are also equal. Okay? Okay, so let's proceed now to theorem 2. A diameter or a radius is perpendicular to a chord, then it bisects the chord and its arc with the same endpoint. So what do you mean by bisect? Meaning it divides the chord and an arc into two equal parts. So in circle C, AR, meaning AR, this is AR, is the diameter. Again, the diameter is also a chord, but it passes through the center of the circle. And FT is a chord. If segment AR is perpendicular to segment FT, then the FY, okay, FY, this one, and this one are congruent. And also, and also, this portion, this arc is also equal to this arc. Okay, this happened only if it's the diameter is perpendicular to a chord. Okay, that's for theorem 2. So let's proceed now to lesson 3, arcs and central angles. So the table below shows the relationships among arcs and central angles. Take time to read and understand. The examples are provided. Okay, so the measure of arc and angles. The degree measure of a minor arc is equal to the measure of the central angle which intercepts it. So if this is our figure, this is circle B, and our central angle is this one. Again, a central angle if the vertex is the center. Okay, the measure of angle ABC, this angle ABC is equal to the measure of arc AC. Okay, example, if the measure of arc AC, meaning if this is 90 degrees, meaning this arc, no, example, if the measure of arc AC is 90 degrees, then the measure of angle ABC is also 90 degrees. Okay, if this is 90, the central angle is also, this is also 90 degrees. Okay, again, that is the first uh, first measurement of a central angle. Next, the degree measure of a major arc is equal to 360 degrees minus the measure of the minor arc or the central angle. So using this one, we will draw again the circle. Sorry if my circle is not perfect. Okay. Okay, this one. Oh, sorry, this is 90, no? Let's assume lang that's 90. This is A. This is B, this is C, and we have point D. So the measure of the degree measure of the major arc. So meaning our major arc here is angle, arc ADC, meaning this one. Okay, the measure of this one is equivalent to 360 degrees minus the measure of arc AC. Okay, the measure of arc AC. Okay, why 360 degrees? Because the one revolution of a circle is 360 degrees. So if this is 90 degrees, so that so the measure of major arc is 360 degrees minus 90 degrees, so that is 270 degrees, meaning this the measure of this major arc is the measure of major arc ADC is 270 degrees. Okay, that's for the major arc. So a semicircle is always equal to half of the circle's circumference. So meaning half, since the one revolution is 360 degrees, so that is already 180, because the half of 360 degrees, that is 180 degrees, no? We will also have arc addition postulate. Arc addition postulate, the measure of the arc formed by two adjacent arcs is the sum of the measures of two arcs. Example, we have the arc CD, this one, plus arc sorry arc arc DA, maklaro. Okay, arc DA. If you're going to add this arc, the measure of this arc plus the measure of this arc, then you can get the major arc. No? You just add those other arc addition postulate. Okay, sum of the measures of the central angle. The sum of the measures of the central angle of a circle with no common interior points is 360 degrees. So this is an central angle, this is a central angle, and this is also a central angle. So if you're going to add your angle 1, the measure of angle 1, the measure of angle 2, the measure of angle 3, that is 360 degrees. Okay, example. Refer to the figure at the left. Find the measure of D, E, no, measure of DEI. This is D, this is E, this is I. So meaning we're looking for this angle or the x degrees. Since this is 35 and this is 105, we know that one revolution is equal to 360. So that is just simply 360 degrees minus 25 degrees minus 205 degrees. So the measure of angle DEI, you just subtract everything, that is 120 degrees. Okay? Don't forget that is 361 revolution of, or one rotation of, rotation of the, revolutionary rotation of the circle. Okay, congruent circles and congruent arcs. So we have congruent circles. Circles are congruent if their radii are congruent. So of course, if these two circles, if this radius is equal to this radius, therefore the circle B is congruent to circle N. Okay, that's for congruent circles. Congruent arcs in a circle or congruent circles, congruent arcs have congruent measures. So congruent uh if a congruent circle C, it follows that all the measures of the arcs are also congruent. Okay, lesson 4, we have arcs and inscribed angles. Okay, we have inscribed angle and intercepted. I already defined this, no? Inscribed angle, this is inscribed angle, and this is intercepted arc. No, ato na nag-define kaganina. Again, this is inscribed angle. Ang inscribed angle if the vertex is on the circle. Kung nasa tunga ang vertex, that is a central angle. Then the arc opposite of your vertex is the intercepted arc. Inscribed angle is an angle which vertex is on the circle and sides contain chords of the circle. We already defined that like a while ago. Okay? Okay, we have theorem 1. The measure of the inscribed angle is equal to 1/2 of its intercepted arc, or the measure of the intercepted arc is twice the measure of the inscribed angles. Okay, for example, angle MAP, meaning angle MAP, you follow lang on what's the M. A, this is A, this is P. So meaning, find this angle. Is inscribed angle intercepts MP, meaning this is intercepted arc, this is your inscribed angle. What is the measure of this angle? Based on the theorem 1, the measure of this angle is just half of your intercepted arc. Therefore, half of 86 is, so half of 86 is 43 degrees. So therefore, this is 43. Okay, that's the simple. If the measure of the inscribed angle, half of the measure of its intercepted arc. Okay? The same na sa, that is obvious, no? Okay, for example, if this is, we don't know that this is 86. We know that this is 43. What's the measure of PN, the arc PN? We know that if the given is the arc, half, no? Half of it is the inscribed angle. See, we have the given, the intercepted arc. You just multiply 2, 43 times 2, that is 86, no? If you're looking for inscribed angle, half of the intercepted arc. If you're looking for the intercepted arc, twice the central angle. Okay, take note. Okay, we have theorem 2. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So we have angle RAK, meaning RAK, and RMK, both intercept RK, meaning kani, no? This one, yeah, di ba, yung naigo na kay kani man gyapon, and this angle, yung naigo is this one. So therefore, this angle and this angle are congruent, no? Since they have the same intercepted arc, so therefore their angles are also congruent. Okay, so we have an example. Okay, theorem 3. If an inscribed angle intercepts a diameter of a circle, then the angle is a right angle. If PEA is a semicircle and PA is a diameter, then meaning, di ba, this is diameter and this is our inscribed angle. Di ba, this is the diameter. So therefore, the explanation why we have 90 degrees, di ba, this is the diameter. The diameter divides the circle into two equal parts. So this is, if this is, what's the measure of this intercepted arc, diba? That is 180 degrees since it is a semicircle. So, by the theorem 1, half of 180 is 90. So, therefore, that is a right angle. So, meaning, if we have the intercepts diameter, it follows now that is already 90 degrees. Okay, so we have theorem 4. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, what do you mean by supplementary? Supplementary angles are two angles that if you're going to add, the result is 180 degrees. So therefore, so examples of supplementary angles are 100 degrees and 80 degrees. No, these are supplementary because if you're going to add 100 plus 80, that's 180. We have also 110 and 70. No? There are a lot of supplementary angles. So, if a quadrilateral is inscribed in a circle, meaning four-sided polygon, inscribed in a circle, meaning it's inside the circle, then its opposite angles are supplementary. So, we have a quadrilateral LPMO is inscribed in circle N, meaning it's inside. Then angle MOL, meaning MOL. Okay, this one. Plus LPM, meaning LPM are supplementary. Opposite ha, meaning at bang. Okay, opposite. Meaning if you're going to add this angle plus this angle is equal to 180. And another angle we have PMO, meaning PMO meaning this angle is supplementary with angle OLP, meaning this angle. Okay, they are supplementary. Again, ang opposite, meaning at bang, supplementary. Okay, for example, this is a quadrilateral. We have angle FON, meaning FON, and NTF. They are opposite angles, meaning at bang. So therefore, if we're going to add this angle plus this angle, the sum is 180 degrees. So therefore, to find y or find the NTF, okay? So to find y, that is 5y degrees, meaning this angle, no, this is 5y plus 3y plus 12 is equal to 180 degrees. So combine like terms. So 5y plus 3y is 8y. Then 180 transpose 12, that is minus 12, no? So 8y is equal to 168. So divide both sides by 8. Y is 21. So therefore, if we're looking for NTF, so angle NTF, since NTF is 5y, we will just substitute y to 21. So 5 times 21 is 105 degrees. NTF. Sorry, angle. So since this is 105, what's the measure of this one? Okay, what's the measure of 105? Since supplementary, what is 180 minus 105? Okay, that is 575, right? So if this is 75 degrees, okay? So if we're going to 105 plus 75, that is 180 degrees, okay? So that's for theorem 4. And for your activities, please refer to your to-do list. Okay, that's for module 4 in grade 10 mathematics. Thank you so much.